Hello, friends. This is Jim with Science Talk. I have a very interesting bit of research I wish to share with you folks here. And this is quite fascinating for me. And I'll read you the headline here. Planetary climate influence has age-old effect. There is such a thing as planetary climate influence which changes the Earth over eons. And now scientists have a better handle on how this happens. So, there is now firm evidence in the ancient rocks of planetary climate influence. A climate cycle that lasts for 405,000 years. 405,000 years. This confirmation of celestial clockwork, the swing in planetary climate happens because the Earth's orbit is periodically distorted by the combined tug of Venus and Jupiter. Has been tracked back through evidence in the rocks for the last 215 million years. So they've got a long data set here. The 405 year cycle, 405,000, 100,000 year cycle, is only one of a series of cycles that changes the levels of sunshine received by Earth as it orbits the sun. Researchers have also known about and documented periodic shifts over cycles of 21,000 years, 41,000 years, and 100,000 years. Now, let's have a little brief pause here. These last three cycles that I just shared with you, 21, 41, and 100,000 years, are part of the Milankovitch cycles. Who was Milankovitch? Milankovitch was a Russian scientist who wanted to find out why did ice ages appear to be cyclic. Have ice sheets advance, they retreat, advance, retreat, and so on. So he wanted to figure out why that was. And during his work and his research, he came up with these three cycles. And basically, they're called, the 21,000 is the wobble of the Earth's tilt of the axis. The Earth is tilted on its axis, varies anywhere from 23.5 to 26.5 degrees, or 23 to 24, somewhere there. But basically, several degree wobble in the tilt of its axis. That, of course, will you tilt it further down or further away. That will change how much sunlight energy is received on the surface, which we usually measure in watts per square meter. The 41,000 year cycle is the precession, or the sequence of the timing of the equinoxes and solstices. And the 100,000 year cycle is changes in the Earth's orbit, what we call the eccentricity. Now, Earth tends to travel around the sun in a not quite circular orbit. It is slightly elliptical. And changes in this eccentricity, that's how we measure the how much ellipticalness is of a orbiting object. It changes over 100,000 years from nearly circular to at its most elliptical for Earth and then back. These are the Milankovitch cycles. Now, Milankovitch had the misfortune of doing a lot of his work during the 1940s. There was something else going on in the world during the 1940s. What was that? Oh, right, World War II. So for a lot of years, his work was largely forgotten. And then there was a resurrection of his work or rediscovery of his work in the 80s. And so on. Now, I will be preparing a video explaining the Milankovitch cycles. As I get more adept with using some of these new software I have here, I can then show you some animation, show you some diagrams so that you get a better handle on how all these cycles interact. As opposed to me just blathering about it, you get to see it and understand better how this changes basically the sunlight reaching the surface, when and where, at what point, the amount of energy that's imparted, and how this will affect seasonalities and climate. So stay tuned for that. That'll be upcoming when I find materials I'm satisfied with. Now, going back to the Milankovics, okay, the 21, 41, 100,000 year cycle have been known to affect the pattern of the ice ages. That's why Milankovic set out to study. The latest study pushes the influence of the longest than back in time to even before when dinosaurs showed up. Although 215 million years ago is right at about the start of the Triassic, which is the first major period of the Mesozoic era. So it's about when dinosaurs, at least the small little guys, started showing up. There are other shorter orbital cycles. When you look into the past, it's very difficult to know which one you're dealing with at any time because they change over the time. The beauty of this one cycle is that it stands alone. It does not change. And this is a quote from Dennis Kent of the Lamont Doherty Earth Observatory at Columbia University. He's also associated with Rutgers University. It is an astonishing result because this long cycle, which has been predicted from planetary motion through about 50 million years ago, has been confirmed through at least 215 million years ago. So, scientists can now link changes in the climate, in the environment, dinosaurs, mammals, fossils around the world to this 400, 500,000 year cycle. And they do so precisely. Such studies are the fundamental explorations of the machinery or the machinations of climate. By understanding how conditions changed in the distant past, researchers can better appreciate the speed and danger of climate change today, driven by human burning of fossil fuels. And relate that as well to atmospheric greenhouse gas levels that are found up, and we can measure in the rocks, we can measure in the ice cores, and so on. Now, you have heard me say in previous videos that yes, the climate has changed in the past. There's no doubting that, and we've got the evidence for that. The key difference is the rate at which the climate changes. It is changing the fastest basically since the start of the industrial age. It's the rate of change. It's warming the fastest. CO2 levels are increasing the fastest. Then that we can see going back in time. It's the rate of change. That's the key difference. That's the main point and thing to understand about this. So this latest research is published in the Proceedings of the National Academy of Sciences. Now, I mentioned earlier about the 100,000 year eccentricity of the Earth. Well, that's because, as I said, the Earth's orbit is basically in the shape of an ellipse. Sometimes it's almost but not quite a circle, and sometimes the orbit gets more elongated, which means, as I said earlier, I like stressing points here, is that the total sunshine that reaches the planet's surface will change. And of course, we got the wobble on this axis, and the tilt relative to the sun changes basically when the solstices and equinoxes occur. That's the precession I mentioned earlier. But the most dramatic change occurs every 400,000 years or so when the elliptical shape is elongated by as much as 5% as a consequence of the gravitational pull of basically other planets, Jupiter and Venus having the most influence. Basically, depending how those planets line up, where they are in relation to Earth, then there could be some gravitational tug that will elongate the elliptical nature of the orbit. Professor Kent and his colleagues have been able to read evidence of this regular cycle in looking at very large cores of rock, which they obtained from a geological feature in the Petrified Forest National Park in Arizona. I've been there. It's a pretty cool place. Rock cores also from ancient sediments beneath New York and New Jersey. There we go. The first samples, ones from Arizona, provided the radioisotopes that geologists use to precisely date rocks. Now, you're probably familiar with carbon-14. Carbon-14 is very nice for looking at several thousand years of going back in time. But if you want to go further back in time, then we're looking at potassium-argon, argon-argon dating methods as well. And these allow you to go further back in time and be able to give you more precise measurements. The second confirmed a pattern of wet and dry periods over long cycles of time. And this is the key thing. Both sets of rocks contain paleomagnetic evidence of the North and South Poles periodical reversals. I've done some videos where I discuss, is the Earth's magnetic fields flipping and all the poles getting ready to flip-flop and all that kind of stuff. So I've discussed that sort of stuff in prior videos. Well, when you have this data of the paleomagnetic evidence, you're able to calibrate when these events took place. You're able to date, we measured, say for example, we measured this level of CO2. We now know when that happened. So you can make an accurate calendar of changing climate conditions. And this occurs every 400 and 500,000 years. Now, they make a statement here that is not really set in stone. So let me share with you what's going on here. The study reveals nothing very significant about the effect of long-term astronomical influences on climate change today. Okay, that's fair enough. Right now, Earth's orbit is near to a circle. In the absence of human interference, Earth should be nearing the end of a long-term warming trend, and according to the astronomical clockwork, should be heading for another ice age. Professor Kent is not so sure. There are other studies that, when they look at the Milankovitch modeling and the forcing and the timing of those three cycles, 21, 41, 100,000 years, according to that, and Earth should be entering a cooling phase already. In fact, should have been into the cooling phase already, but it has not. So if Earth was entering a warming phase along with the added CO2 levels, then we could really be having a bad situation for civilization. Now, recall also the videos I did about the AMOC, where I talked about all the fresh water that gets inputted into the surface of the oceans and what that does in terms of shutting down the conveyor belt. Okay. I am one of those oceanographers that is of the opinion that climate change / global warming can bring on an ice age for the simple reason of basically, and it's not simple of course, but it's a complex mechanism, but for the major reason of shutting down AMOC, shutting down that meridional overturn circulation, which is a heat transport mechanism. So you end up with a greater gradient of hot tropics and cold polar regions, but by shutting that down, you then I talked about what happens to the ecosystem, but also when you shut down the conveyor belt, the planet starts to cool down rapidly. So, like everything else, this is a very complicated system, and this is why research is done, to try and answer this. So there are those who say, well, Milankovitch says we should be in the middle of a cooling phase. Others saying, well, we're still in a warming trend, and then we start cooling down to an ice age. Well, this is where you come into how you analyze and interpret the data, and this is what scientific debate's all about. But this is interesting in that we can now have some sort of a timetable. Just look at the cyclical nature of the climate, juxtaposed with the Milankovitch cycles, and then extrapolate or equate that to what is happening today. And then we can make some sort of estimation, some sort of prediction on where the climate is heading and what this might mean for human civilization. So, because as I said, they're able to construct an accurate calendar of when the events occur, when it's warm, cold, and so on. And then, again, looking at the rate. That's always the key. Think of your basic calculus, your derivative, right? The rate of change. Or even algebra, the slope of a line, for an average rate of change. But anyway, so I thought this is a fascinating work that's done here, and I wanted to share that with you. So thank you for your time, and we'll talk soon. Hey folks, just a reminder to please subscribe and click the bell so you know when I drop a video. Please share my videos. Please tell others of my channel and of the work that I do. I also hope that you will consider becoming a patron at patreon.com/Science Talk with Jim Massa, where from time to time I upload videos there exclusively for my patron subscribers. Details in the description box below. Thanks.